For the last video on chapter 12, the cardiovascular system, I want to take a look at the ABO blood typing system. I think it's a little bit important to understand that. And then I'm going to take a look just real briefly at the vessels and compare them and talk just a little bit about those. So, and everybody's probably heard of the blood typing system, the ABO. This is what with the common antibodies and antigens we look at to describe what type of blood type we have. So, what type blood are you? You have four choices. You have type A, B, AB, and O. And then if you take in the RH factor, that's the plus or minus. But for right now, I'm just going to take a look at the ABO system. We're taking a look at what's on the red blood cells. And the antigen, you have two choices, antigen A and antigen B. Someone who's type A has antigen A on their red blood cells. In this case, they are shown by little blue circles. If you have type B, you have the B antigen on your red blood cells. In this case, they're shown as these triangular purple things. And so if you're AB, you have both the blue circles, the A antigen and the purple triangles. And again, it's not quite that simple, but that's what they're showing in this illustration. If you're type O, you don't have either of them. You don't have the A or the B. Okay, so you also need to take a look at what's in the plasma. So I either have the A antigens or I have the A antibodies. I have them one or the other. So type A, I have the A antigen, so I have the B antibodies in my plasma, floating around my plasma. If I have the B antigen, I have the A antibodies floating around in my plasma. If I have both A and B on my red blood cells, I have neither in my plasma. And if I'm type O, since I don't have A or B on my red blood cells, I have the A and the B in my plasma, those antibodies. Okay, so what does that mean? If I go to give blood or receive blood, if this type A antigen comes into contact with the type A antibodies, this little circle in their model here, those circles will stick on here. So this would stick on this, and then on another, and on another, and it would agglutinate. So what does agglutinate mean? It will clump or cluster. It would cause little blood clots in your blood. So obviously I can't mix those two together. Just like these antigen Bs, I can't mix them with the anti-B antibodies. They would cause it to agglutinate. So if I'm type A, I have to avoid this one because it would agglutinate. I have to avoid that one, or it would agglutinate. So type A can only give to other type A's and to type AB. Okay, if I get rid of some of that. Okay, if I take a look at someone with type B, again, obviously they can give to type B people, but they would have to avoid this because these would cause it to stick to this and cluster and agglutinate. So type B cannot give to type A. It could give to type AB. Okay, so it could give to B and AB. If I take a look at the type AB, well, they can't give here because the round ones, the A's, would agglutinate here, and they can't give to they can't give the type B, they can't give the type A, they can't give the type O. They could only give to AB. because they would cause it to agglutinate, the blood to agglutinate. Okay? If I take a look at type O, well, when I take a look at their red blood cells, they would not agglutinate with anything. So they could give, obviously, to themselves. They could give to AB, they could give to B, they could give to type A. That's why type O is the universal donor. They can give to anybody. And if I take a look at type AB, since they don't have either of those antibodies, they can actually receive blood from anybody. So type A is the universal recipient. So if you're type O, which I am, in theory, I can give to anybody. If you're type AB, you can get blood from anybody. Okay? That's our ABO system. When I take a look at the vascular system, I think something that's really kind of interesting, if you could take all your vessels and stretch them out in one straight line, you would have somewhere between 60 and 100,000 miles of blood vessels. And put that in perspective, Earth at its widest point is 25,000 miles at the equator. So in theory, you could go around the world 4 times with your vessels. Now, how can that be? Well, most of that is these really small microscopic parts that are going to nourish the cells. If I take a look and compare these real quick here, arteries have they do not have valves. They don't need valves. They're going to be thicker and stronger because that's where the pressure is. Since there's a lot of pressure, they don't need valves. This is going away from the heart. So if this was the heart here, it's going to go out the aorta, and that goes systemic. It's going to go to the body, and it's going to actually give the nourishment to the cells at the capillaries, and then it's going to come back to the heart. All of it's going to end up coming, except that to the heart itself, is going to come to the inferior and superior vena cava. Those are veins. They do have valves. Why? Because it's low pressure. And if I didn't have valves, blood would go this way, and blood would go one way, this way, and then gravity would take it all the way back down the other way. So basically, there's valves in it. Once it goes so far, it'll stop. So it can't go back down. And then it'll go further, and it'll stop. So it can't go back down. Okay? If I take a look at kind of the size of these, my aorta, which all the blood's going to come out of the heart in that one tube. Going across here, I'd have millions and millions and millions of red blood cells at a time going through here. Across here, I would have hundreds of millions of them. Well, this gets so small as it goes down. By the time it gets to the capillary, how big are those? Only one red blood cell can fit at a time through the smallest part of the capillaries. So these are microscopically small. They're only one cell layer thick. So that's why most of our vascular system is going to be made up of that microscopically small part, the capillaries. So of this number here, most of that is going to be made up of the capillaries. The capillary, and it's called the capillary bed, that's the only place that nourishment of cells takes place. Through the arteries and through the veins, we don't nourish cells through them. They're too thick. Fats, carbohydrates, the water, nothing can get through them. But here in the capillaries, they're fenestrated. They have, which means they have little gaps in them, little holes in them. So the fluid spills out and allows it to nourish the cells on the front end, on the arterial end, and then they pick it back up on the venous end and then join back into a venule. The largest part leaving the heart is an artery. They become smaller until they become an arteriole, they're called, go to a capillary, and then the small vein is called a venule and ends up in a vein that dumps back into the heart. Okay, that's the last talk on this chapter. I will give you the chapter test. For this video, I want you to write ABO at the top of your test. That'll be worth 2 points on your test. Okay? Thank you. Stay safe.